Hey, it's Horner, and these are the projectile motion exercises, and we're going to do number 1 through number 4. All right, here we go. For the very first one, we have Billy Joe standing on a bridge, and when Billy Joe is standing on the bridge, we know that the bridge kind of looks like this. Really not, but anyway, so here's the bridge. And Billy Joe is standing here, kicks a stone off the bridge, and whee, it falls down to the ground. They want us to find out what is the height of that bridge. So they want us to find the height of the bridge. To find the height of the bridge, we know that the height of the bridge is going to be delta y. The things that they give us, so let's look. It has a horizontal velocity of 3.5 meters per second, so that is Vx original, so the original speed in the x, and that is 3.5 meters per second. And they also tell us that it goes from left to right 5.4 meters. So notice everything we have is in the x direction. We want something in the y direction. So I know that if I want to go from x to y, the bridge between the two is finding the time. So let's find the time. We know that velocity in the x is equal to the distance in the x divided by the time. So time is equal to distance in the x divided by the velocity in the x. Let's plug everything in. So that's 5.4 divided by 3.5, and you get 1.54 seconds. Now that I have the time, I can use my equation for the acceleration in the y direction. So that's VOY, so original speed in the y, times t, plus 1/2 of gravity times time squared. Remember, at the top, when you kick the stone, it is only moving in the right, and then it starts to fall, and it falls because gravity, which we know is 10 meters per second squared, is pulling it straight down. But in the y direction, your original velocity is equal to 0 meters per second. So now we can plug everything in. We want delta y. I know VOY is 0, so this whole thing goes to 0. That's equal to 1/2 of gravity times time squared. This would be 5 times our time, which is 1.54. Don't forget the square. That's where people really go wrong, so be careful with that. And that gives us 11.9 meters. So that is your final answer. If I was scoring this on a test, then I would score it 1 point, 2 points, 3 points, 4 points, 5 points, 6 points, 7 points, 8 points. On the AP exam, if they were scoring it, then it would be in purple. They would say the equation and filling it in is worth 1 point. Doing this is 1 point. You have to have both the number and the unit. For doing this much is 1 point. You have to have everything to get that point. And then you also get 1 point for this. So that would be the AP physics scoring. So there's a difference between the two. Next one. If the stone would have been kicked harder, how would this affect the time to fall? So here we're going to answer it by saying that if I kick it harder, it has more Vx, and so then that would increase just the speed in the x, but it would have no effect on the y, and so therefore your time would be the same. Okay, so the time to fall would be the same. In the next one, it says, in the movie, The Gods Must Be Crazy, there is a pilot in an airplane. The pilot drops a bottle out of the airplane. So we're going to say that the airplane is right here, and we'll put some wings on it, put a little tail on it, and they drop a bottle. When they drop it, it does not fall straight down. Instead, it follows this path. And it's because, remember, the velocity of this airplane is greater than 0. So it's moving to the right, so the bottle starts just like it would be shot out of a cannon, moves, and then it comes down. So they give us two things. One of those things they give us is they say that it has an altitude of 500 meters. So that's my delta y. It says also that right here we have 400 meters, and that is my change in x. They want to know how fast was the plane flying when the bottle was released. Again, we have a y and an x. We need to find out what is the speed of the plane in the x, because remember, the plane is only going in this direction. We want to know how fast was that bottle shot out of the airplane, or when it was let go, how fast was the airplane going? So to do that, we have to say Vx is equal to delta x over the time. We don't know the time, but we do know we can use the equation delta y is equal to v oy times t. Remember, this is the original speed in the y, plus 1/2 of gravity times time squared. Why is gravity positive? Well, just like in the last case, down is positive because that's the direction of motion. If we look at the previous problem, same thing. As we move in this direction, it is positive, so everything is positive there. I meant to mention that earlier and forgot. So let's go ahead and find out how much time it takes. We know the original speed in the y is 0, so this term goes to 0. We're looking for time. We know delta y. Delta y is 500, so that's equal to 1/2 of g, so that would be 5 times time squared. We're going to do more math here, so time now is equal to the square root, so 500 divided by 5 is 100, so our time is equal to 10 seconds. Now we can plug everything into this equation in order to find the speed. So our delta x is 400. We know our time is 10. So that would give us 40 meters per second. Again, scoring for me would be 1, 2, 3, 4, 5, 6, 7, 8. Scoring for the College Board or for the AP test, you would get 1 point for this, 1 point for this, 1 point for these things, and 1 point for your answer and your units. Let's go on to the next one. This is number 3. Tad drops a cherry pit out of a window 1 meter above the ground while traveling down the road at 18 meters per second. So they want to know how far horizontally from the initial dropping point will the pit hit the ground. If I have a car, okay, so here's my car, and there's a window here, and the car is moving in this direction, so it has a positive velocity in that direction. When I let go of the cherry pit, it's not going to fall straight down. Instead, it's going to stay with the car, and it will make that parabolic curve, and it will hit the ground. I know the car looks like it's off the ground. Maybe we'll just do this. All right, there we go. So the car will continue to move, so the car will be right here when the cherry pit hits the ground. It flows with it. We're assuming here there is no air resistance. Okay, so that's really important. They said draw a picture of this situation. Whoop, that's what we did here. It also says if the car continues to travel the same speed, where will the car be in relation to the pit where it lands? They will be in the same place. So when I dropped it, it was right above here. Now it lands in the same spot because they're both moving to the right at the same speed. The distance from the cherry pit down to the road is delta y, and that's equal to 1 meter. It is traveling down the road at 18 meters per second, so that is our positive velocity in the x direction, and so that is equal to 18 meters per second. Let's go ahead and let's figure out now, well, what do they want us to find? They want us to find how far does it travel in this direction. So this is our delta x. So once again, we know that we're going from something in the y to something in the x. Anytime you go from y to x or x to y, remember time is your bridge that makes the two work. So let's go ahead, let's find the time to fall. Time to fall, because it's falling, is in the delta y. That's equal to the original speed in the y times time, plus 1/2 of gravity times time squared. Delta y, we know, is 1 meter. Velocity in the y is 0, so this whole term goes bye-bye, and we have 5 times our time squared. So that would be t squared. And now what we need to do is go through and solve this. So this would be 1/5 square root is equal to t. And so our time here is equal to 0.45 seconds. Awesome. Let's move on and let's find out how far it went. We know the speed in the x direction. We know delta x and t, so we're looking for delta x. So delta x is really just vx times t. Our velocity in the x, remember, is 18. Our time is 0.45. And so when you multiply those two together, you're going to end up with your answer. And I need to calculate that really quick. Hold on. All right, 18 times 0.45 is going to give you 8.1 meters. And so that's our distance right here. All right, this is number 4. Last one we're going to do. Ferdinand the frog is hopping from lily pad to lily pad. So let's get out our lily pads here. And another lily pad. And the frog is jumping from one to the other. We know the distance between them is 2.4 meters. We know the frog is jumping up at an angle, and it is 5 meters per second. Notice that this is the original speed, but not in the x or in the y, but in both. So it's going up at an angle, and we're trying to figure out what in the world is this little angle right here that's making with the horizontal. So that is what we are looking for. This is 2.4 meters. It says it takes 0.6 seconds to go from lily pad to lily pad. So that means that this total time to go left to right is 0.6 seconds. That means to go up and back down would be 0.6 seconds. Let's figure out what is the speed in the x direction. Now, how are we going to do that? Well, we have a time, we have a delta x. That means that v in the x is equal to the change in position over the time. So let's plug everything in. This is 2.4 divided by 0.6. And if I do 2.4 divided by 0.6, I end up with 4 meters per second. So that makes the velocity in the x 4 meters per second. Let's draw a triangle. So this triangle, I've got two sides of this triangle. I have this side, which we said was 5 meters per second. And now I have the velocity in the x, which is 4 meters per second. I want to know what is the angle right here. So this is the hypotenuse, this is the adjacent. I know that I'm going to use cosine because cosine is ca. And so now I can solve. So I can say, well, I know that the speed in the x is equal to 5 times the cosine of the angle. I know that that x is 4, and that's equal to 5 times cosine of the angle. So if I want the angle, that's going to be cosine of the angle is going to be equal to 4 over 5. And that means the angle, now I have to divide both sides by cosine, that would be the inverse cosine of 4 over 5. That will give you your angle, and that is 37 degrees. And that is the end of the first video on the problems.